Okay, we should be live now. Okay, let's start the stream. Okay, is it good? I said I give him to 2, so it should be green now. Green health should be good. Okay, let's just start straight away. Okay, second portion of the walkthrough of the functions worksheet. This part will be talking about sketching, the questions I put there about regarding sketching and the miscellaneous ones. So from 21 until the end. Thumbs up. Okay. So sketch the function. You're given a function fx equals to x minus 1. The question A will always ask you to find the values of the x and y intercepts. If your y-intercept means your x is equal to 0. Y-intercept here, the points over here share what have what characteristic? X equals to 0. X equals to 0. So f bracket 0 equals to 2 bracket 0 minus 1 equals to minus 1. Y-intercept. X-intercept is your fx equal to being equal to 0, whereas x-intercept is on your x-axis. All these points share a common characteristic, which is your y, your fx in this case being equal to 0. Okay, this can go. So 2x minus 1 equals to 0. Rearrange 2x equals to 1 to bring over to dy x equals to 1 half. Okay, so y-intercept, y and x-intercept done. B. Sketch fx for the domain -3, -3, x4. So since this is a straight line without the absolute value, what you only need to do is to find the start and end points. So in this case, x equal to -3. When x equals to -3, this is your starting point. This is your starting point. F bracket -3 equals to 2 bracket -3 minus 1. This is equal to -6 minus 1 -7. X equals to 4. F bracket 4 equals to 2 bracket 4 minus 1. This should be equal to 8 minus 1, which is 7. Okay, so we have this. Then since okay, wait, just checking the audio. Okay, then since you don't have a V shape, since you don't have a V shape, you don't need to. I mean, the question will ask you to find the x and y intercept. Fx goes here, x goes here. This is -3 and 4. I drew it to center. Okay, it works like this. If it's a line, just draw the graph first, then you can draw the line. If it's a curve, you want to draw the curve first because aiming the curve against the points is way harder than drawing the curve and putting down the points. If it's quadratic, you want to draw the curve first. It will be way easier. If it's linear, you can use ruler for that. Rulers are accurate enough to go for lines. To go for the points, so you do the points first. -3, -7. Roughly here lah. I'll just say here. Then 7. Actually, this should be on the left. And then this should be at the bottom. And then 4 is here. So you get this and this and this point. Summon up the line. Ruler. Summon up the ruler. Connect. Okay, there you go. So yeah, this is that. So your y-intercept is -1. Table of y-intercept. x-intercept is 1/2. Label your x-intercept. It's pretty accurate consider all things actually, because I do have a grid that I can follow. For you guys it's agak-agak lah. For you guys it's agak-agak, it will be fine because sketching doesn't mean you have to be accurate. You don't have to draw 1 2 3 4. No, you don't have to do that. You don't have to go 1 2 3 4 5 6 7. No, you don't have to do that. Okay, none of that. You don't have to. Okay, just roughly, it's a rough sketch. Roughly sketch it to do. Okay. Next, this is our graph done. Okay, if you want to be careful, you can label it. So put the name of the function beside it. So fx equals to 2x minus 1. Okay, so next is state the range. Okay, state means one answer, one line of answer. You don't need to show any workings because it is expected you can just read it directly from the question or the answers before this. Range is the range of your values on your vertical axis. In this case, -7 to 7. So this is your range. This is your domain. This is your domain. This is your range. Okay, domain is your x-axis values. Range is your vertical axis values, y-axis, fx-axis, depends on what you want to call it. They all mean the same thing. Okay, so your range in this case it is -7 to 7. So -7 less than or equal to fx less than or equal to 7. You can write it that way. If you want to write it in set notation, you can also do that, but nah, not necessary. Just use the inequalities to do. Okay, this is C. State one answer will do. Donkey, find the inverse f inverse x. Okay, find the inverse. This is just 2x minus 1. The inverse is relatively easy. So f inverse equals to x. 2x minus 1, 2f, substitute x with f inverse. Rearrange x plus 1. Rearrange to bring over x plus 1 over 2. Okay, and then also do this is your answer. E. State the domain and range for f inverse. Okay, so this is where we will need to teach this concept. The domain and range for your fx is reversed for your f inverse. So f inverse, your range should become your domain because we are going from your fx back to your x. Okay, that's why it's called f inverse. And your domain for fx will become the range of your f inverse because fx is x to the result. F inverse is from the result back to x, back to your starting point. That's why the domain and range are basically reversed. So the domain of your f inverse, it is equal to the range of your fx, which is already given by f7. If you want to write it like in inequality notation, please take note that the middle letter over here would change because for the domain we are talking about f inverse as a function itself. So it's from x you start, you go through f inverse x to get your result. That's why it looks like this actually. That's why it actually looks like this. Yeah. So because of this, your domain for f inverse will always be your x, because you are treating f inverse as a function in terms of x. Therefore, your input, which is your range of your which is the values on your domain, are still the x's for the f inverse. Therefore, we will be using x over here for our domain. Okay. Range is, in this case, it would be the domain for your original fx, where in this case it would be -3 and 4. But again, since our result in this case is said to be the f inverse itself, we will write this over here. So -3 has been with f inverse in between -3 and 4. Okay, question 21 done. I definitely heard this house. Oh no, this is, never mind, this one. Okay, question 22. Actually, all the questions are the same. Okay, question 22 doesn't have really that much of a difference. So one, but I will still do it anyway, because yeah, I cannot say that, oh, you just look at yourself. Then what's the difference from there and learning from frontal? What if you need the explanation? X equals to 5 minus 2x. Again, find x and y-intercept. Y-intercept easiest. Just let x equals to 0. So g bracket 0 equals to 5 minus 2 bracket 0 equals to 5. B. No, not yet. X-intercept is equal to your gx being can be found by letting your gx be equal to 0. So 5 minus 2x equals to 0. Rearrange 2x equals to 5. X equals to 5 over 2. Yeah. Okay. Next, B is sketching. Okay, so same thing, you want to find the endpoints. When x equals to, because this is just a line without your absolute value. So x equals to 2. When x equals to 2, when x equals to 2, your g bracket -2 equals to 5. Yeah. And then find the starting point and end point. Yeah. 2 and 5. Oh no, I should have. Give me a moment. Okay, there you go. And then jot down the x and y intercepts. Yeah, there we go. So this is graph for 32. 5 minus. Okay. This is the range. Basically same thing. Your range in this case is the values of your vertical line. So in this case it is -5 to 9. This is an after effect of eating lunch. Why am I getting tired? Okay, anyway, the range is a range of your vertical values. In this case, it's -5 to 9. Okay, done. D, find F inverse. Find G inverse. G is given as 5 minus 2x, simple enough. Uh, 5 minus 2, 5 minus 2, G inverse equals to x, which bases equals to 5 minus x. Okay, G inverse is 5 minus x over 2. Okay, and then yeah, question E, state the domain and range for G inverse. So same thing, the domain for G inverse is the range of Gx. So you will get -5 between you will get between -5 and 9. This is with x. Range of G inverse, you will get this will be equal to the domain. This will be equal to the domain of G inverse. So we have this. So we now have settled domain and the range of the inverse function G inverse, and now we have settled this question. Okay, onward to the next. Imaging server. How long has it been? Imaging some water. 90 minutes. Given the function fx, let me just give a moment. Okay. Yeah. Walkabout. And okay, let's continue. Good. Okay, continue. Given the function fx equals to absolute value 3x minus 1, you can find a value, same thing. First, find the value of the x and y intercepts. And same thing, y int is when your x equals to cosine. X cosine. X is cosine, fx cosine equals to absolute value 3 bracket cosine minus 1. Okay, so yeah, it's basically this. Then this should be equal to absolute value of minus 1, which is equal to 1. X-intercept is when your fx is equal to 0. So your 3x minus 1 absolute value equals to 0. If you bring out the absolute value to the opposite, you will get the plus minus, but plus 0 and minus 0 has no difference whatsoever. So this just turns into 3x minus 1 equals to 0. You can do this directly. Then rearrange the terms, you will get x equals to 1/3. You can do this yourself lah. Okay, x and y intercept done. B, sketch a graph for domain nav 3, 7. When x is negative 3, your fx, your f bracket negative 3 will be equal to absolute value 3 negative 3 minus 1. This will be equal to 3 minus 3 is negative 9, so negative 9 minus 1 absolute value. This will give you negative 10 absolute value, which can be translated in 10 phases. Yeah. Okay, that ensures that enough space for the other question. Yeah. Okay, anyway, so this. So yeah. Anyway, then when x is equal to 7, your f bracket 7 will be equal to 3 bracket 7 minus 1. This would be 3 times 7, 21. 21 times 1 absolute value of 20. Yeah. So 21 minus 1 is 20. Absolute value of positive numbers does absolutely nothing to them. So this will just get you 20. Yeah, that is all. Let's play one. Yeah, this will get you 20. Yes, thumbs up. Okay, then this is a V shape. Okay, but since you already have the x, you would need to connect from your start point to x-intercept, from your start point to your x-intercept back to your end point, which is kind of tedious because we have to find our x-intercept separately. But because for question A we already have our x-intercept, it is much easier. Okay, so negative 3, 7, so I'll put it like somewhere over here, I suppose. Got down. Actually, maybe I can shrink it a little. Let's put it here instead. This is your fx. 10 and 20. 10 boxes? No. 1, 2, 3, 4, 5. Okay, this is definitely good enough. Okay, so your starting point is negative 310. So negative 3, where I put 4, 4, 4, 4. Okay, actually if I want to do this, I need to put it here instead. Yeah. This point. Then, up a bit, this point. Then 7, 20. Okay, but since it's originally a straight line, it just bounces, this portion just bounces back up if you apply a negative sign to it. So this graph will touch the x-axis no matter what. No matter what. Yeah, no matter what. Therefore, x-intercept where? 1/3. Okay, and x equals to 0, x equals to 1/3. My calculations, it should be somewhere around here because the here is a bit flawed. So at the end, okay, you have this V shape, done. There's nothing else you need to do. You can point out the y-intercept. This is 1. You can find the y-intercept. This is 1. But other than that, yeah, nothing else already. And then if you want to be careful, fx equals to absolute value 3x minus 1. Okay, done. Done. Okay, so question C said the range of fx. In this case, range again is the vertical values on the vertical axis. So you start from x-axis 0, you go all the way until 20. Because this is absolute value, it has no negative numbers whatsoever. So yeah. Okay, next. Yeah. So range of values of fx is from your starting point to your endpoint on the vertical axis. So in this case, your range will be 0, fx to 20. Fx is between 0 to 20. Yeah, within this. Okay, donkey. Find the values of x when fx equals to 4. Okay, this is solving. So the fx is given as 3x minus 1. So 3x minus 1 equals to 4. 3x minus 1 equals to plus minus 4. Getting rid of the absolute value. Going over 3x minus 1 equals to 4, or 3x minus 1 some part of this is definitely making me feel more tired than usual. Nav 4 plus 1, nav 3, 3, nav 3 divided by 3, nav 1. Yeah. That's all. Both of these do fall within the domain stated anyway, so yeah, it wouldn't affect, yeah. Okay, I definitely did. On. Need to continue through this. It's half an hour already. What the fuck is it? Is it because it's getting hot? But, but yeah. Afternoon energy is usually quite low actually. Like the period from 2 to 5, the energy is so low. The energy is like really low. And then the energy in the morning is like good. Yeah. Okay, given the function, actually let me just open up this. Wait, isn't this the same one as on? Why did I put the let's say wind this up. Wind this up first. X equals to 0. Yeah, I think I don't have to say much about this. You can push on your own already. This is the match on top. Equals to 2, negative 2. I might jump some unnecessary steps, so if you are confused, please. Fine. Okay, so this is quite this is quite this is quite spoon feeding, not gonna lie, but I think it's another way of encouraging self-study. Like I give you the resources, you study on your own. Because the amount of time we meet in class is just not a lot, not gonna lie. It's just not a lot. Yeah. Okay, sketch rough. 2 to left 2 to 4. This is 9. 8, 4, 3, 2. This should be GX. 2, okay, here, and then 2, 2, 3, 4. Again, I'm joining this because I have agreed to follow it within CSP, but for you guys, just agak-agak will do. You have your S intercept 5 over 2, 2.5. One line. In this case, take out a ruler. and connect the dots. Okay, yeah, there we go. Then you can label your x and your y intercept as well. In this case, it's pretty accurate. Not gonna lie. Then fx equals to absolute value of 5 minus 2x. Okay, done. So question C, same thing, say the range. Values 1 from 0, the bottom to the top, 9. Gx between 0 and 9. Okay, yeah, done. D, find the value of x when Gx maps to itself. So we want to find the x such that Gx being equal to absolute value of 5 minus 2x will map to itself. By the way, reshaped graphs do not have inverses because the horizontal test fails. That's the horizontal test fails. Yeah. And basically the reverse relationship is 1 to many instead of many to 1. So no, they are not. They don't have inverse functions. Yeah. Okay. Anyway, yeah. So this one, removing the absolute value will introduce a plus minus on the other side. So you have 5 minus 2x equals to x, or 5 minus 2x equals to negative x. First case, 5 equals to 3x, to move over, plus minus negative becomes plus. Negative becomes plus. Okay. And then x and 3, you want to throw it over to the other side to do division, so x equals to 5 over 3. Negative x plus 2x, this is 2 minus 1, you get x. Yeah, 2 minus 1, you get 1. 1 is equal to 5. So 1 is equal to x, so x is equal to 5. That's that. Yeah, that's it. Okay. 4 page done. Onwards. New page. 2 new pages, please. One more. It might be a bit slow. This energy speed low. It's 41 minutes. Okay, question 25, class 1 for sketching. Basically the same thing. I will just go through it. I don't think I need to explain. Y and fx function the same way. Yeah. X equals to negative 5, y in this case equals to 2, but 2 minus 7 we get 5, 2 minus 35, we get negative 33, absolute value, remove the negative sign, yeah, there you go. Two minus 42, oh okay, I was like, huh? 不真奇怪嘿 and there we go. 2 plus f7 minus 7 minus nav 7 nav 5 minus become plus 7 5 35 2 plus 35 37. I was so confused. I was like, how do I get do I get two negatives? Okay, sketch 35 and 40 how much should this graph be? 4 2 0 1 2 3 1 2 3 4. Okay, let's do it here. 5 37 roughly here 6 40 absolute everything is set 2 over 7. 2 over 7 is so small around here. Okay, there we go. Rearrange rearrange and give 7 yeah, okay. 7x equals to 2 minus 5 which bases this one 7x move over, so negative 7x move over to the other side, positive 5 move over to the other side, plus becomes minus, minus becomes plus, plus becomes minus, they switch bases, so you get 7x equals to negative 3, x equals to negative 3 over 7. Again, in this case, again, spaces 2 by 2 move negative 5 move over becomes plus 5. So x equals to 2 plus 5, which is equal to 7. X equals to 1. Okay, two answers. Going to check here. Okay, done. This is until 25. I still have 5 more questions. Okay, 26. Fx equals to 3x plus 2. Fgx equals to 9 minus x over 2x. And x is not equal to 0. Find the value of g inverse 3. This will require me to find gx first, no matter what. And this is fine in this case because gx is inside. So if you want the outside one, you want to find inside. It is easier. This is easier, so let's get to it. F G is G substituted into F. I can let it become my object to replace my x within fx. So I get G, I get 3 spaces. So I get 3gx plus 2. This will be equal to 9 minus x over 2x. Then this will be ratio 3gx equals to 9 minus x over 2x minus 2. Gx equals to everything divided by 3. For fraction, the thing that you are dividing directly multiplies to the bottom. 2 times 3, 6x minus 2 over 3. Yeah, this is what you get. Okay. Then if you want, you can combine this together. So make top and bottom, make the two terms both have the same denominator. 3 how to become 6x? You multiply by 2x. So this multiplied by 2x, this multiplied by 2x. Minus x minus 4, minus 1 minus 4 minus 5 over 6x. And then else left to do, this is your answer. Done. Yeah, done. Okay, yeah, done. Very good. Okay, x not equal to 0. Definition because denominator, yeah. G inverse 3 is the same thing as finding when this equals to 3. To demonstrate this, it can actually be written like this. G inverse 9 minus 5x over 6x equals to x. I can let this be equal to 3. Then the x that I find will be the result. Yeah. So 9 minus 5x over 6x equals to 3. 9 minus 5x over 3 times 6x, 3 times 6, 18, 18x. Rearrange 24, 20, wait what? 23x equals to 9. Then minus 5x move over to become plus 18 plus 5, 23. X will be equal to 9 over 23. Yeah, that's the answer. So yeah, that's the answer. That's the answer. So basically, your value of your G inverse 3 will be equal to 9 over 23. Okay, that's it. Yeah, done. Okay, 27. Given that the function fx equals to a plus b over x plus 5, where f negative 4 equals to negative 1 and f negative 1 equals to 2. Find the values of a and b. This will basically be substitution. Yeah. Substitute and do simultaneous lah. F negative 4 equals to negative 1, so x when x equals to negative 4, f negative 4 equals to a plus b over negative 4 plus 5. This is equal to 5 minus 4 is just 1, so this is equal to a plus b, and this is equal to negative 1. When x equals to negative 1, f bracket negative 1 equals to a plus b over negative 1 plus 4 plus 5. 5 minus 1 is 4, a plus b over 4. Okay, then this is equal to 2, then you do something. I think I accidentally took it off just now. Sorry about that. So a is equal to minus 1 minus b. Substitute into the other one. So I get minus 1 minus b plus b over 4 equals to 2. Minus b plus b over 4 equals to 2. Negative 1 move over becomes plus 1. 2 plus 1 is 3. Negative b minus plus b over 4. Minus 1 plus 1 over 4, you get minus 3 over 4. So negative 3 over 4b equals to 3. Negative 3 over negative 3b equals to 3 times 4, 12. B equals to 4. B equals to negative 4. 12 divided by negative 3. B equals to negative 4. Yeah. Let me just double check. Four plus 1. 4 minus 1 minus. Yeah, correct. Yeah, correct. Then you want to find A. So in this case, A equals to negative 1 minus negative 4, so plus 4. Minus 1, 4 minus 1 is 3. So A is 3, B is negative 4. Done. Okay, so question B. Hence find f inverse. Your fx at the end can be written as 3 plus 3 minus 4 over x plus 5. Yeah. Then this is you want to find the inverse. Okay. F inverse this entire thing equals to x. So same thing, let your original fx in this case is whatever it is. In this case, it is whatever that's in the bracket. So rearrange. Okay, this might prove to be relatively tedious, so let me just make the denominator combine the left hand side into one fraction first. Yeah. So 3x plus 15 minus 4 over x plus 5 equals to y. Okay, we can write this. X plus 5, I can move over to the other side to multiply. I can move over to the other side to multiply with my sorry. I can move over to the other side to multiply with my y. So I get, let me just see. So I get 15 minus 4 is plus 11. X times y is xy. 5 times y is 5y. X on one side, y on the other. No x on the other side. So you get 3x minus xy equals to 5y minus 11. X factorized out, 3 minus y equals to 5y minus 11. Bring over, 5y minus 11 equals to 3 minus y. So this is that. Okay. Okay, so back, f inverse y equals to x equals to this. F inverse x equals to this. Denominator cannot be equal to 0, therefore x cannot be equal to 3. Okay, that is your answer. Given the function, give me a moment. Yes. Continue. Continue. So Okay. Given a function fx equals to fx equals to x divided by 2. Okay, this is better. Okay, so fx equals to x minus x over 2 minus 2. 3x equals to 3x plus p. Okay, p is a constant. This means that it doesn't change. That's all. Yeah, then find the following values. Okay, so f inverse 5. Same idea. F inverse x plus x over 2 x equals to x over 2 minus 2 equals to x. If I let my inside the bracket, which is basically my fx, be equal to 5, the x that I will be finding is the x over here, and that's basically what we want. Therefore, yeah, just go through this. F2 bring over becomes plus 2, x over 2 equals to 7, 5 plus 2 is 7, 2 bring over to multiply, x equals to 7 times 2, you get 14. Okay, done. That's basically the answer. Okay. Wait. Therefore f inverse 5. Therefore f inverse 5 equals to 14. That's all. Yeah. Okay, next we have b. B asks for the value of p if f inverse gx equals to 6x plus 6. Okay, unfortunately this will require us to find f inverse explicitly. So let's do that. Will be over here. Yeah. Since you follow the border. Cool. I think should be within the border. It should. Okay, so fx is this. F inverse. Yeah. I will have to find f inverse explicitly. So f inverse x over to same thing. Let x over 2 minus 2 equals to y. X over 2 equals to y plus 2. 2 bring over to do multiplying, x equals to y times 2 y, 2 times 2 4, so x equals to 2y plus 4. Therefore f inverse y equals to x equals to 2y plus 4. F inverse x equals to 2x plus 4. F inverse g is then 2 bracket 3x plus p plus 4. Multiply your 2 inside into the bracket, you get 2 times 3 6x, 2 times 3x 6x, 2 times 3 6x plus 2 times p 2p plus 4. Okay, so now you can compare and contrast with the one given in the question. This is equal to 6x plus 6. Therefore, by comparison, 6x equals to 6x. Obviously, x with x, 6 equals to 6. No contest. 2p plus 4 equals to 6. no x with no x, therefore constant with constant. 2p plus 4 equals 2p plus 4 equals to 6. Rearrange 2p equals to 6 minus 4, 2p equals to 1. Yeah, there we go. Yes, there we go. Okay, cool. Question 2 done. And then B done. C. Hx if hf equals to this. Okay, so given inside find outside. Not that easy. Okay, so hf is equal to x minus 5 over 3. This is also equal to h bracket x over 2 like this. Hey, x over 2 minus 2. You want to let this to be equal to y as well. So let x over 2 minus 2 equals to y. X equals to, I just speed one a bit. I just speed a bit because this exact has been found in this exact expression has been found in equation C, equation B. Yeah, I think I can do this instead. Yeah. What's the email that means? Okay, I think this is better actually. Okay, x equals to 2y plus 4, then x equals to 2y plus 4, so h bracket y equals to, substitute in 2y plus 4 minus 5 equals to 3, so you get 2y plus 4 minus 5 is minus 1 over 3 plus 4 minus 5, yeah, and then minus 1, so over 3, and then with this you can do anything else, so this should be your answer. Therefore hx, therefore therefore hx is equal to 2x minus 1 over. Okay, this is your answer. Yeah, that's basically it. Okay, 28 done. Okay, next 29. Let me put it here. 29. The functions f and g. F like not the variable is keep in mind that I can do that. Keep in mind that the variable keep in mind that the variables can change. Okay. Yeah. Keep in mind that the variables can change. Yeah. So that's that. Okay. Find f inverse 5. Same idea. You have f inverse 2z minus 1 equals to z. Let 2z minus 1 equals to 5. Continue to use pink for this. Let 2z minus 1 equals to y. 2z equals to y minus plus 1. Z equals to y plus 1 over. Yeah. Then f inverse a. No, what am I doing? I'm not finding f inverse x. The x minus 5. Let this be equal to 5. Basically same idea from before. And then you rearrange 2z equals to 5. Minus 1 becomes plus 1. 5 plus 1 is 6. And then 2 bring over 6 divided by 2 you get 3. Yeah. So therefore f inverse 5 equals to 3 in this case. Yep, there we go. Okay, so question B, gfz. Gf is f into g, so I will have 5 over 2z minus 1, replacing my z in g, and then my minus 3 copy over like this. So originally is 5 over z minus 3. Now it's 5 over my z gets replaced by fz, which is 2x minus, which is 2z minus 1. So now it's 5 over 2z minus 1 minus 3. This is equal to 5 over 2z minus 4. Do you have anything to do with this? No, not really. There's no calculations. There are no further calculations needed. Therefore, there are no further calculations needed. Therefore, this should be your answer. Remember to write the definition. Because z is at the bottom, it cannot be equal to some certain number. In this case, how can you check? Again, let's write 2z minus 4 not equal to 0. Rearrange the terms. 2z not equal to 4. Z not equal to 2. Therefore, z cannot be equal to 2, or else if you put this number in, the entire function will be undefined. Yep. Okay. There, question 29. Done. Okay, 30. Absolute cinema. Okay, 30 is given that h inverse equals to this. H inverse x equals to p over q minus x. We are given that h1 equals to 3 and h inverse 5 equals to negative 1. Find values of p and q. So for this one, conditions are given already, so you just substitute. You basically just substitute and do simultaneous. The first condition seems a bit awkward because it's h or h inverse, but we can just swap it to get h inverse anyway. So h inverse bracket 3 equals to 1. You can do this. Okay. Then who is that? Okay, so h inverse 3 equals to 1. Okay. So basically you can although it gives you h, you can solve it to become h. Okay, then substitute the values in. Just substitute the values in. So h inverse 3 means your x turns into 3. Means your x turns into 3, and then this should be equal to 1. So the moving the p minus moving the q minus 3 over to the other side to multiply, you get p equals to q minus 3. Okay, yeah, did that first. H inverse 5 equals to 1 equals to p divided by q minus 5, and this is equal to negative 1. Yeah. Okay. So q minus 5 you can move to the other side. P equals to negative q minus 5, like this. Yeah. Then since these two things are equal to each other, since p equals to this and equals to that as well, you can combine them together to form a single equation. So multiply your negative inside to the bracket, you will get negative q plus 5. This will be equal to q minus 3. Rearrange q and q, 2q, 2. Negative q move over to become plus, 2 plus q is 2q. Negative 3 move over to become plus, so 5 plus you get 8. So 2q equals to 8, therefore q equals to 8 divided by 2 you get b equals to q minus 3, q is 4, 4 minus 3, this is equal to 1. Okay, done. You want to be careful, at the end write p equals to 1, comma q equals to 4. Okay, done. 31. Okay, 31. Given that f g inverse and f g inverse, find the values of a. Okay, this okay, find the values of a and b. Okay, so fg inverse, given f and g inverse already, so just directly do the composite. So a x plus b, but x gets replaced by g inverse, so a bracket 2x minus 4 over 2 plus b. This is equal, you can rearrange this first, and this is simplifiable. Your 2x minus 4 over 2, you can simplify it because you can divide everything by 2, so this becomes 1, this becomes 1, this becomes 2, therefore this can be simplified into a bracket x minus 2 plus b. Expand, so a times x ax, a times negative 2, negative 2, negative 2, negative 2a plus b. This is equal to s4 plus 3x as given by the question. Therefore, compare and contrast. By comparison, ax equals to 3x, x and x cancel, a equals to 3. Negative 2a plus b equals to 4, a equals to 3 sub inside, negative 6 plus b equals to 4, b equals to 4 plus 6 equals to 10. Yeah, so we have this. Wait, let me just double check. Yeah, this is correct. So therefore your a is 3, b is okay, good, and b is 10. Okay, there we go. This is 31. 4 more questions left. So okay, this is 32. Let me save. And 32, given that 2. Given that fx equals to ax plus b, this is another comparison question. I put this many. Given that I put this many, you can obviously expect this one of these to come out in UIE. I don't remember where. I don't remember if I put this in paper 1 though, but paper 2. Okay, so x plus 6. Okay. Anyway, find the values of a and b. Okay, so in this case, you'll be required to find f a g inverse first because you're only given g but not g, but the composite function uses g inverse. So find g inverse first. Not that hard to find. You can speed run this actually, but no, I'm not going to teach the method because g inverse equals to x. G inverse means I replace my x in g with g. I replace my x in g with g. Rearrange. G inverse x equals to x minus 1 over 3. Plus 1 becomes minus 1. 3 move over to do divide. You get 3 move over. 3 going over to do division. You get this thing over here. Yeah. Yeah. I'm still recording. I'm still streaming. Yep. Indeed. Okay. Okay. Continue. So g inverse x got. Now you can find f g inverse directly. So f g inverse is g inverse in f. So f is ax plus b. A bracket x minus 1 over 3 plus b. Again, you directly replace it. This one, the g inverse is not unifiable, so that will be it. Multiply your a inside, you get ax. You get ax minus a over 3 plus b. Split it into x and non-x terms. You get ax over 3 minus a over 3 plus b. So this will be equal to the one given in the question, which is x plus 6. Okay, comparison by comparison. So x will compare with your x. So your ax over 3 will compare with your x. X and x can this can be written as x or a over 3 multiplied by x equal to x. X and x cancel each other out. You'll get a over 3 equals to 1. Therefore, bring 3 over to multiply. A equals to a. Yeah. Yeah. Okay. Yeah. A equals to okay. Then a equals to 3. You can sub it into the other portion. So we also have, now let's start the issue on the next page. We also have negative a over 3 plus b equals to 6. Okay. A is equal to 3. Type it in. Negative 3 over 3 plus b equals to 6. Negative 1 plus b equals to 6. Negative 1 move over to the other side, becomes plus. 6 plus 1, you get 7. So b will equal to 7. And then that is all. So yeah, so the answers are a equals to 3 comma b equals to 7. Okay, we are done. Next page. Can finish within 2 hours? Probably. Okay. Question 33. Given that gx equals to mx minus n over x plus 4, definition x next one equals 4. As an inverse function, g inverse x equals to negative 4x minus 3 over x minus 2x not equal to 2. Okay, find the values of m and n. Find the values of m and n. Then also find GGO. Okay, so okay, let's do this. Okay, so GG negative, GG inverse. You absolutely can do that, but you'll be very tedious, so I don't know what you can do. What you want to do instead is to directly reverse it. So if you can find G inverse from G, you can also find G from G inverse. So G inverse x equals to this entire thing. Therefore, G bracket flipping these two also gets rid of, also flips your G between normal and inverse both per se. Therefore, we can have this. Now we just need to let this entire thing over here be equal to y. Find x in terms of y, then we can find x. Then we can compare contrast to find m and n. Move over to multiply. So x times y, xy minus 2y. Isolate everything that has x, move over. Everything that does not have x, move to the other side. So you get this x. X you can factorize it out. You get negative 4 minus y bracket equals to negative 2y plus 3. Bring over to the other side. Actually, let's just get rid of the negative signs first. Entire thing multiplied by negative because you will need it later. Entire thing multiplied by negative, you get 4x plus xy equals to 2y minus 3. X you factorize out, you get x bracket 4 plus y equals to 2y minus 3. Okay, 4 plus y you can move over to the other side. X equals to 2y minus 3 over 4 plus y. Therefore, this is your gx and gy equals to this entire thing. Y minus 3 over 4 plus y. Convert back to gx. 2x minus 3 over 4 plus x. Compare and contrast. This is equal to mx minus n over x plus n. Okay. Yeah. Okay, this is equal to this. Therefore, if you compare and contrast, you will get the following. By comparison, 2x minus 3 equals to mx minus n. 4 plus x is 4 plus x, 4 plus x is 4 plus x, so that one you don't have to compare. This one. Okay, and then 2x equals to mx, m equals to 2. Negative 3 equals to negative n, n equals to 3. Done. Done. Okay, B. GGO. Okay. G0 is 2 bracket 0 minus 3 divided by 4 plus 0. 2 times 0 is 0. So this will just give you negative 3 over 4. GGO is G bracket negative 3 over 4 negative 3 over 4 which is equal to this 2 bracket negative 3 over 4 minus 3. This should be equal to negative 3 over 4 plus 4. Okay. Two times this, 2 you can cancel out with the 4 division. You get negative 3 over 2 minus this one. You can make it the same denominator, so we can combine it later because we want to get a number from this. So 6 over 2. Okay, 3 is 6 over 2. Divide by this one. 4, the denominator 16. 4 times 4 is 16. Denominator is 4, so you get 16 over 4 for this. Okay, then this one with minus 3 minus 6 is minus 9 equal minus 9 over 2 divide 16 minus 3 is 13 over 4. Flip around, division becomes multiply, reciprocate to get this. So 4 and 2, since you're multiplying together, one is top and bottom, one is top, one is bottom, you can cancel each other out. This becomes 1, this becomes 2. 9 and 13, you cannot cancel each other out whatsoever, so you are forced to stay there. Therefore 9 times 2 18, negative 18 over 1 times 13 13, negative 18 over 13. That is your answer. Okay, 34. Given two functions, fx equals to x squared plus 1, dx equals to 3x over 5 minus. Okay, we're going to find fg3. You want to find fg3. So easiest way to do this is to calculate G3 first and then sub it into F. Yeah, so you don't have to find FG explicitly. So G3 is equal to 3 times 3 divided by 5 minus 2 times 3. Okay, this is equal to 2 times 3 is 9, 2 times 3 is 6, 5 minus 6 is negative 1. So you get a negative 9 out of this. Then FG3 is F bracket negative 9. So okay, so yeah, this is negative 9 negative 9 squared plus 1. So this is 81 plus 1, you get 82. Yeah. Yeah. Yes, this is 81 plus 1, so you get 82. Yeah. Yeah, this is question A done. Okay, so question B, if GH equals to this, find H. H is the one inside, so this is a bit easier. GHX equals to 3hx over 5 minus 2hx, and this is equal to 9 minus 3x over 2x minus 1. Okay, this is very troublesome. Yeah. Then at this point you will cross multiply. Okay, so 3hx bracket 2x minus 1 equals to 5 minus 2x hx 5 minus 2h bracket 9 minus 3x. Expand. Yeah, just expand. Just already expand. You want to find hx, this is the most straightforward way possible. It's just very troublesome. 3 times 2, 6. X hx minus 3hx. 5 times 9, 25. 5 times negative 3x minus 15x. Negative 2hx times 9. Negative 18hx. Then my nef 2 nef 3 plus 6 x hx. You can move around the terms. This and this directly cancel each other out, which is what we want. And then I can isolate my hx as. So negative 18hx move over to left hand side. I get 18hx minus 3hx equals to 45 minus 15x. 18 minus 3 is 15. 15hx equals to, you can factorize the 15 out, so you know where this is going. Factorize the 15 out because you can, and then 15 move over to divide. 15 cancel, 15 cancel each other out, you will get a 3 minus x. After this, there's nothing else to do, so this would be your answer. Okay, does HF inverse exist? This is one of a kind trick question. Does HF inverse exist? First and foremost, HF can be written as 3 minus bracket x squared plus 1. So 3 minus x squared minus 1 equals to 2 minus x squared. Okay, this is a quadratic. Do quadratic functions have inverse functions? No, because quadratic functions in this case it is a prime phase. The horizontal line that passes through it passes through 2 points at once. Therefore, it is not a triple. It is not a. It doesn't have, because of this it doesn't have an inverse function. Yes, because of this it doesn't have an inverse function, and because of this, yeah. So yeah, it doesn't exist. 大概写一写就好。You just write something you think is the answer. So, HF inverse does not exist as HF itself is a quadratic and quadratic and quadratics don't have an inverse. Okay, that's question C. Last but not least, 35. Now we use elemental and dark. It's the last question anyway. Okay, same thing while sketching. So fx is given as 4 minus 2x. I need to sketch a graph of its absolute value, so it is this, and for the domain 0x3. So again, you want to find the endpoints first. So x equals to 0, y equals to 4 minus 0, which is equal to 4. X equals to 3, we get y equals to minus x equals to 3, y equals to yeah, I will see how. Let me just write it properly. Y equals to 4 minus 2 bracket 3 absolute value. This is equal to 4 minus 6 negative 2. Negative 2 changes to positive. And then because it is a V-shaped graph, it will hit the x-axis, so you will also need the x-intercept. Yeah, you also need the x-intercept. We will also need the x-intercept. So x int y equals to 0. So this will lead for equals to 4 minus 2x being equal to 0. Then bring over the 2x. 2x equals to 4. X equals to 2. Okay, so we now have our x-intercept as well. This is question A, by the way. Therefore, we now can plot 0 to 3. Interesting. I'll put it here. So 1, 2, 3, 4. So x int is 2. X runs from 0 to 3. When x is 0, y is 4. When x is 3, y is 2. When x is 2, y is when x is 2, y is 0. So again, a line to come off. Let me just dengan guna. Okay, so this is the graph itself, and yeah, so this is y equals to absolute value 4 minus 2x. Okay, then so question B says, hence based on the graph in A, 1, find the corresponding range. Okay, again this is a 1 mark, so the state only. Your range of your fx of your y in this case is equal to 0 to 4, because that's where this is. Yeah, so therefore 0 to 4 range, so it is y, or it's technically not fx anymore, it's just y. Yeah, it's technically not fx. Yeah, 0 to 4. Okay, so question 2, find the type of relation is of the function. This relationship is a many to 1, many access to a to 1 y. Yeah, many access to the same y. So this is a many to 1 relationship. Many to 1, many to 1, many x to 1 y, many to 1. So question 3, by using the line test, certify whether fx has an fx absolute value has an inverse function or not. Line test, just draw. So dun, 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 dun. Okay, so by the horizontal, what you write is basically like this, right? The horizontal line passes through more than 1 point on the graph. More than 1 point on the graph. The horizontal passes through more than 1 point on the graph. Therefore, according to the horizontal line test, this function absolute value of x does not have a inverse function. Okay, does not have an inverse function. Okay, done. Actually, these are questions. Line itself is 1 mark and the explanation is another mark, so 2 marks. Anyway, I am done. 2 hours? Yeah, within 2 hours. Hell yeah, okay. So anyway, I'm done. Yeah, that should be it. Okay, thanks guys for tuning to this walkthrough. Honestly, it will be a recording when you watch it, but thanks for watching regardless. I will not need to rest.